If you're building solar street light proposals for an EPC project, you already know the pain. One wrong battery or panel size, and the system either shuts down early or the budget blows up. Hi, I'm Wao Wu. I'm the co-founder and sales director at ADNLITE. In this video, I'll show you a simple, repeatable way to design a solar street light system. No guessing, just clean energy math. Let's start with the battery. You might see a label like 12.8V 10Ah and wonder what it really means. Here's the key formula. Energy in watt-hours equals voltage times amp-hours. So a 12.8V 10AA battery is 12.8 times 10, which equals 128 watt-hours. But don't stop there. In real life, you can't use all 128 watt-hours. Many lithium batteries have low battery protection. A common number is about 15%. That means the system won't let the battery discharge too deeply to protect battery life. And there's another real-world detail. If the battery dips under about 80% state of charge, charging can slow down, so the battery can take longer to refill. I learned this the hard way. In my early tests, I ignored these limits. Some lights shut down earlier than expected. That's why I recommend oversizing the battery. In most projects, I aim for 1.5 to 2 times the actual daily energy usage. Here's how that sounds in practical numbers. If your light uses about 100 watt per night, I recommend about 150 to 200 watt of battery capacity. If your light uses about 200 watt per night, I recommend about 300 to 400 watt. If your light uses about 300 watt per night, I recommend about 450 to 600 watt. If your light uses about 400 watt per night, I recommend about 600 to 800 watt. This buffer helps cover protection limits, system losses, self-discharge, cold weather, and usage spikes. Now let's size the solar panel. A lot of people think this: if I buy a 100W panel, I get 100W all the time. Not true. A 100W solar panel running at full power for 1 hour makes 100 Ws, but real sunlight is limited and charging has losses. In many regions, a practical average is about 4 to 5 hours of peak sunlight per day, so a 100W panel might produce something like 300 to 450 W per day, depending on conditions. Now let's talk about charge controller efficiency. Your panel power goes through the controller before it charges the battery. Basic PWM controllers can be surprisingly inefficient. Some cheaper PWM controllers are only around 60% to 70% efficient. So with a 100W panel and 4 peak sun hours, if your controller is PWM at 70% efficiency, you're looking at about 100W x 4x070, which is around 280 watt per day. But if you use a high-end MPPT controller, efficiency can reach 90% or more. With that same 100W panel and 4 sun hours, 100W x 4x090 equals about 360 W per day. And don't forget weather and seasons. Even in sunny places, you'll have cloudy or rainy days. In winter months, you might lose daylight hours and solar angle. A panel that generates around 400 Watt in summer might only provide around 250 Watt in winter. Next, let's calculate daily energy consumption. This is where dimming mode changes everything. Most solar street lights use dimming to stretch battery life. Two common strategies are motion dimming and auto time dimming. Motion dimming: with motion dimming, the LED might run at about 30% power when nobody is around. When motion is detected, it jumps to full brightness for a short time. So for a 30W LED, if it stays at 30% most of the night, it might consume around 150 watts. If it's a low traffic area, it might use only around $100 or even less. That's because the light behaves more like a 10W or 15W unit most of the night. Auto time dimming. Auto time dimming is different. A typical profile is first 4 hours at full brightness, then the next 8 hours at 40%. With a 30W LED, That kind of schedule can use about 210 W. It never dips below 40%, so lighting is more consistent, but energy use is higher. Now let's put it together with a practical case. Let's say we have an 8-meter pole and a 60W LED. In this example, the LED outputs around 11,000 lumens. We want to run it all night with a 30% motion dimming profile. This setup might need about 300 W on each night. Now think like an EPC contractor. You don't want the light to fail after 2 cloudy days. A common guideline is to plan for 2 to 3 days of low sunlight backup. So you may want total stored energy of about $600 to $900. Now the panel. If you want to recover around 300 wands per day, plus some margin, a 120 double of panel can generate around 300 to 450 watt per day under typical sun conditions. That depends on sun hours and controller type. With good MPPT, you can get closer to the higher end. If your area has less sun or you want faster charging, you might choose a 150 W panel. So here's the full workflow. Calculate nightly energy use in watt hours. Choose your dimming strategy first because it changes everything. Size the battery with real usable capacity in mind, usually 1.5 to 2 times daily use. Then size the panel based on sun hours, controller efficiency, and worst season conditions. And finally, check physical and safety constraints before locking the configuration. For free solar street lighting project proposal, welcome to reach us at website www.adnsolarstreetlight.com, WhatsApp +86 1586 7141854.